Hi there. Today I'm going to talk about the attribute selection for clustering before we actually get into the clustering algorithm itself, just to help you understand the thought process that goes on as you do data mining. In the previous videos we looked at selecting a random sample, and then we looked at looking at some of the variables and some of the pre-processing you need to do in terms of handling missing values, creating dummy variables, etc. But one of the things that's really helpful in clustering is what I've done is I've taken all the attribute column names from my data set and transposed them and created a table where I'm going to decide, am I going to include this in the analysis or not? Is there any kind of pre-processing that needs to be done for each of these? So what I'm doing here is I'm going through one by one, and I wanted to show you my thought process as I go through this. Like I said, with this data set that I'm using, which is about virtual students and their performance in their classes from 2015. So here I started it. I have a column that says include yes or no. I have data type, which I'm not going by the data types that were in your exam last. I'm just saying if it's numeric, it's not numeric. So it's not the, the ordinal, the ratio, etc. We don't need to get down to that level of detail for this analysis. And then any comments in terms of things that I need to do regarding that. So when I'm looking at my attributes in here, my first one is term code key, which is the semester, but it's in the banner code, which is a number. I'm not including that. I don't think it'll be helpful because it's going to, k-means is going to do averaging, and averaging semester codes will not give me meaningful information. Next is the RAND value. That's how I selected the 1,000 rows. I'm not including that. I'm also not including the key, which is like a primary key. You never want to use that in any kind of algorithm, whether it be clustering or anything else. Actually, it will skew the results. And because, especially in classification, it will actually show this as being the biggest predictor, which this is not a predictor in and of itself. But it actually, this is what leads to overfitting. If you have something that is a key, will definitely lead to overfitting. That's actually meaningless. And then on top of that, gender, I'm going to include, but it's a categorical data, so I'm going to convert it to a dummy variable. Race, ethnicity, I'm going to include, but that's categorical, I need to convert it. Age is numeric, I'm going to include that. And then age group is grouping, and I'm going to include this, but I want to talk a little bit about this because usually having two variables that are essentially capturing the same information can sometimes be problematic, but I want to see what happens and show you what happens in the clustering algorithm when we include both. So one is more distinct. The age has a higher, what we call cardinality, meaning it's got more distinct values. The age group is compressing that data into smaller number of variables, but I do want to use both in this case to see the two should line up in the clustering, but we're going to see if they align as a part of this process. Student type, I'm going to include, that is categorical, I'm going to convert it. Full-time, part-time status is categorical, I'm going to convert it. Major code, you're going to find that I can't do that. You'll see that you'll get an error in XLMiner when you do clustering, and when you try to convert to a dummy, if it has too many distinct variables or values, it can't convert it. So major code, there's more than 30 majors, so it's going to give me an error saying there's more than 30 distinct values. It can't convert it to a dummy. So I'm going to leave that one out. Same thing with major description. Zip code is probably going to be the same thing. There's going to be more than 30 distinct zip codes. So unless I want to come up with my own categorization scheme, I'm not going to be able to include zip code. Reading placement, I am going to include. That is a dummy variable, so I'm going to convert it. Writing placement, yes. Categorical, so convert it. I'm not going to include the score. The score is what results in the writing placement and math placements. So because I have this information here, and there's actually problems with that data set, there's missing some scores. So I'm not going to include that. I'm going to include instead of the math placement. Turn GPA, yes, that had some missing values in it, but I fixed that. Cumulative GPA, yes, and these are numeric, so I don't need to do anything to them. They're fine. Total term credit hours, yes, that's numeric. I'm not going to do the part of term code. I'm going to do campus description, but that's categorical, so I need to convert it. Subject code, this is actually relating to the course that they're taking. I'm not going to include that. That's too granular for this kind of analysis. I'm not going to do the course number. I'm not going to do the course. I'm not going to do the CRN. High school grad year, I'm going to say yes. That's numeric, so I don't need to do anything to it. I'm just going to type this in here. Final grade, yes, that's numeric. I don't need to do anything to it. Grade group, I'm going to say yes. That's like A to C and then D to F. But it is a categorical data set, so I need to convert it. Delivery method, yes, that's virtual versus, or online versus face-to-face versus blended. That's categorical. Developmental means, indicator means, did they test it at college level or not? I'm going to include that, but that is categorical, so I'm going to convert it. Credit hours, yes, that is numeric, so there's nothing I need to do with that. GPA hours, yes, that's numeric. Nothing I need to do with that. And then quality points, it takes the grade and the GPA and multiplies it. So I'm going to include that. Probably don't need to, but I'm going to just to see what happens. So I wanted to show you this as I was going through this, because like I said, I'm taking a real data set. I'm going to take it through, I'm going to cluster it, but I wanted to show you all the different things that I'm going through in order to do this. And in this way, I mean, you can sit there and try to write it down on a piece of paper, but I find that this is the best way to come up. So now I can go through and I'm just going to choose the ones that said yes. And now when I go into Excel Miner, I know what do I need to convert, and then what am I going to include in the final analysis when I do clustering. So I highly recommend you do this with your project data sets. Look at each thing individually. Think about, does it make sense to include? Because just remember that in clustering, it's using Euclidean distance, determine the space between various variables. It may not make sense to have everything included, so you need to be, you need to think about what that actual attribute is encapsulating, and then decide, does it make sense to include this in a clustering algorithm or not? And if you're not sure, you can throw it in there, but like I said, it could skew the results, so you need to look at the results after the fact to see how homogeneous are those clusters, and what's the average for each individual attribute, and what does it mean, which again I'm going to show you in my next video, because now I'm going to go and deal with my data, convert these to dummy, and then I'm going to come back in my next video and actually apply the algorithm. So stay tuned.